In 1734, a very exciting revolution happened in the world of mathematics. A mathematician named Alexis Claude de Clairaut introduced a brand new notation called function notation. This notation takes the standard y equals and replaces it with f of x, the letter f with x in parentheses. This is really cool because it simply tells you by looking at it that an equation represents a function. It's equivalent to y equals, but it does tell you a little bit more information. But notice the only difference between the original and the new notation is that the y is changed to f of x. And in fact, it's completely the same. We see y equals 7x minus 8. We can rewrite that f of x equals 7x minus 8. You know right away by looking at that in function notation that, boy, this graph is going to pass the vertical line test. Every value I put in for x will give me a unique value out. It's going to be a function all the way. You can see going down through the examples that we simply take out the y and replace it with f of x. We can also go backwards. Notice here we had f of x equals negative 8x plus 3. We can take out the f of x and replace it with y equals. Evaluating functions is something you've done for a long time. You take a number and plug it in. In middle school, they say evaluate y equals 3x plus 2 when x equals 7. And you plug the 7 in for x, and you get a number out. Using function notation, they say f of x is 3x plus 2, and they say find f of 7. That simply means take 3x plus 2, plug the 7 in, and figure out what your answer is. In our first example here, we have f of x equals 6x minus 10. They say find f of 6. The first thing I did was I wrote the 6x minus 10, and I put the x in parentheses. The x in parentheses is very useful, especially when negative numbers become involved. To evaluate the function, simply take the 6 and plug it in for the x. So 6x minus 10 is 6 times 6 minus 10. And I calculate the numbers, and it comes out to be 26. So the value of f of 6 equals 26. Again, I simply took 6 and plugged it into the function. It's like I dropped a 6 into the machine, and the machine spit out a 26. The second example here says find f of 9. Well, I'm going to take the 9 and drop it into my machine. When I drop it in, I have 6 times 9 minus 10. The machine spits out a 44. That's really all we're doing. We're given a rule. The rule is 6x minus 10. We're dropping the number in, and it's spitting something out. Part C and D, I'd like for you to try these right now. Please pause the video, and then come back, and we'll see how you did. Let's see how you did. F of 14, we drop the 14 in. It plugs it in for x, and the machine spits out a 74. F of 20, I dropped a 20 into the machine. It spit out 110. Sometimes functions have exponents, or things that are a little bit fancier. This function says f of x is 10x to the third plus 2x squared plus 5. The first thing I do is I take the x's and I put them in parentheses. I always do that. It really helps me keep things organized. Once I've put the x's in parentheses, then I can do my evaluating. F of 6. I'll take the 6 and drop it into the machine. That means wherever I had an x, I'll put a 6. So I have 10 times 6 to the third plus 2 times 6 squared plus 5. So drop a 6 into this machine, it spits out a 2,237. B, they want us to evaluate f of negative 9. Well, I'm simply dropping negative 9 into the machine. When I drop negative 9 into the machine, it looks just like this, and it spits out the number negative 7,123. There's a couple more examples here, C and D. I'd like for you to pause the video here, drop those numbers into the machine, see what the output is when you put these numbers in. Please pause the video here and come back to check your answer when you're done. Let's see how you did. When I put a 14 into the machine, I got 27,837. When I put a negative 5 into the machine, I got negative 1,195. In our next example, they ask us to determine if the ordered pair is a solution for the equation. We have an equation x minus y equals 2. We want to know if the numbers 2 and 4 work in this equation. In other words, if I plug them in, will it be true? Another way they might ask this question is say, is the point 2, 4 on the graph x minus y equals 2? But no matter how they ask it, we're simply plugging the 2 in for x and the 4 in for y. Notice when I do that, I have 2 minus 4, which is negative 2. Negative 2 does not equal 2. And so the point 2, 4 is not a solution. In example B, they ask us to evaluate 4, 2. Is the point 4, 2 a solution, or is the point 4, 2 on the graph of this line? Well, again, I plug the numbers in. I substitute them in. 4 minus 2 gives me 2. I have 2 equals 2. That is true. Therefore, the point 4, 2 is a solution to this equation. Or if I were to graph that line, that point 4, 2 would be on the graph. Example 4, we have a parabola. It has an x squared in it. Y equals 2x squared plus 3x minus 2. Please pause the video here and determine if these ordered pairs that are given are solutions to the equation. Let's take a look and see how you did. The first thing I did was put my x's in parentheses, and then I plugged the numbers in. On the part A, I ended up with 25 equals 25, which is true, so that is a solution. On part B, I ended up with 5 equals 12, which is not true, so that one is not a solution. Example 5 has us working with an inequality. Y minus 2x is greater than 4. Please determine whether each of these ordered pairs is a solution to that inequality by plugging them in. Please pause the video here, then come back and let's see how you did. In example A, when I plug 4 in for x and 0 in for y, I end up with negative 8 is greater than 4. Clearly that's not true, and so the point 4, 0 is not a solution. On part B, I plug negative 1 in for x and 2 in for y. I end up with 4 is greater than 4. 4 is not greater than 4. That's not true. And so the point negative 1, 2 is not a solution. Part C, I plug in 0 for x and 6 for y. I work through that, evaluate it, and I see that x is greater than 4. Because 6 is greater than 4 is true, then the point 0, 6 must be a solution. It must be on the graph of that inequality. The last thing I want to show you today is how to find a missing value. These are cool little puzzle-like problems, and they tell us we have a line. The equation is 3x plus y equals 10. So we have the function 3x plus y equals 10. And they say that we're using the ordered pair D4. If I drop a D into the machine, it spits out a 4. But the D is actually a number. What is the number that I stick into the machine so that it gives me a 4? Well, what I'm going to do is take the D, plug it in for x, and the 4, plug it in for y. When I do that, I have 3D plus 4 equals 10. And I solve that equation, I find out that D equals 2. The value of D is 2. So if I drop a 2 into my machine, it will give me a 4. Or if I were to graph the line, the equation 3x plus y equals 10, the point 2, 4 would be on that line. Similarly, if I plug a 2 in for x and a 4 in for y into the equation, it will make it true. Notice how there's a lot of different ways of thinking about this, but they all really mean the same thing. Example 7 is the last example. We have a function, 3x plus y equals negative 8, and we drop a negative 4 into that machine, and we want to know what number is it going to spit out. This is just like the example we just did. I'm going to ask you to please pause the video here, then come back and let's see how you did. In this example, I plugged the 4, the negative 4, and the k into my equation. I ended up with k equals 4. And so the value of k is 4. That means if I put a negative 4 into this machine, the 3x plus y equals negative 8 machine, it will give me a 4 as an output. Or if I were to graph the line 3x plus y equals negative 8, the point negative 4, 4 is on that graph. And this is the basics of working with evaluating functions and determining whether points are solutions to given equations.